Right, in this video we are going to graph the tangent function. So just like sine and cosine, we've got all of these aspects of our graphs that can change, starting with what's called the amplitude. Now with sine and cosine, that makes sense that we call it an amplitude. It's the distance between the midline and like the top of our wave. But with tangent, that doesn't make sense, because tangent we get these graphs that essentially kind of look like an x cubed graph, and those things just repeat. So it doesn't make sense to necessarily call that an amplitude. However, it has the same effect. So it's going to stretch these graphs out vertically. And then we can have, a phase shift where we move it from side to side, a vertical shift where it's moved up or down. The period of these graphs would be pi divided by k. So that's different. Sine and cosine, it's 2 pi divided by k. But tangent is only pi divided by k, because we repeat the tangent values every pi units around the unit circle instead of every 2 pi units around the unit circle. So our period is a little bit different here. We start with pi divided by k, not 2 pi. The domain is going to be all real numbers, except x can't be pi over 2 plus any integer multiple of pi. So what that means is we have a vertical asymptote at pi over 2 because the tangent of pi over 2 is undefined. And if we add any multiple of pi to that, so if I add 1 pi or 2 pi or negative 4 pi, any integer multiple of pi added to pi over 2 will give me another vertical asymptote. So all of the spaces in between these graphs are vertical asymptotes. I'm going to quickly show you that in Desmos. I've graphed tangent x. This graph just repeats indefinitely on both sides. But I've got a vertical asymptote at x equals pi over 2. And then if I add any multiple of pi to that, even negatives, negative 2 or negative 3, any multiple of pi added to that is going to give me another vertical asymptote. So that's what that means. And then our range is all real numbers. We're going to span the entire y-axis here. Okay, so let's go ahead and jump into graphing tangent. Tangent is going to be the one table that we make where we're going to have to be a little bit more worried about where we start our x values, because we want to see one full cycle of tangent, which means we want to see this one whole graph here with vertical asymptotes on either side. Okay, so y equals tangent x. The quote-unquote amplitude here is 1. The period is pi divided by k, so the period here is pi. And there is no phase shift, and there is no vertical shift. So when we make our xy table, this is where tangent differs from the rest of our trig functions. If we want to see one full cycle of tangent, we actually want 0 not to be our starting point, but we want it to be our middle x value. And I say 0 as long as there's no phase shift. If there is a phase shift, that's the value that you want in the middle. So if you think about the other trig functions, we always start with 0 unless there's a phase shift, in which case we start at that phase shift. With tangent, it's not our starting x, it's our middle x. So since there's no phase shift, I want my middle x to be 0. And then what you have to think about is the length of the period is what I want to see. So I want to see pi units, and if 0 is in the middle, that means I want to take that pi and split that in half, and I'm going to do a half on either side, which means I'm going to go to pi over 2, and I'm going to go to negative pi over 2. And if you think about the distance between negative pi over 2 and positive pi over 2, that's going to be a distance of pi. Okay, so think about like negative 1/2 to positive 1/2. That distance would be 1. So negative pi over 2 to pi over 2 is a distance of pi. So I'm going to split that up, and I want 0 in the middle. That's what that's going to look like. And then I can do my halfway points between 0 and these values. So halfway between 0 and pi over 2 would be pi over 4. And halfway between negative pi over 2 and 0 would be negative pi over 4. Okay, so I'm going to go ahead and label my x-axis here. So we want 0 right in the middle. We've got pi over 4 and pi pi over 2, and then we're going to do the same thing to this side, negative pi over 4, and negative pi over 2. Okay. Now, when we get the y values for this, if you put 0 in the middle, or whatever your phase shift is in the middle, that is going to be the location of the center of one of your tangent graphs, which means this is going to be 0. Okay, so I know I'm going to have a point right here. Now, if there's a phase shift, your y value is still 0. It's just that this would not be 0. It would be some other. It would be moved left or right. If there's a vertical shift, then it would not be at 0. It would be at whatever that vertical shift would be. So if the vertical shift is up 2, then that would be at a y value, or a y value of 2 there. Okay. So know that it's going to be, 0. It's going to be on the midline in the middle. The 2 on the end are going to be your vertical asymptotes. So at negative pi over 2 and at positive pi over 2, that's where we're going to get our vertical asymptotes. All right, and then the only other thing you got to remember is that for pi over 4 and negative pi over 4, just remember the direction with which a tangent graph goes. So a tangent graph is going to be like an increasing graph. So that means that at pi over 4, we're going to get 1. And at negative pi over 4, we are going to get negative 1. And those are the only points that you have to know, and then you can make your one cycle of your tangent graph. Okay, so that's going to be negative 1 here and positive 1 here because it's an increasing graph. And that's it. Okay, so the big difference here is making sure that you put 0 in the middle, and then knowing that you've got your vertical asymptotes on the outside of that, and then does it go up, does it go down? That's all you need to worry about there. Okay, so here we have y equals 2 tangent of 2x. In this case, the amplitude is 2. The period is pi divided by k, so it's going to be pi over 2. No phase shift and no vertical shift. So we make our table. Again, no phase shift, so I want 0 in the middle. And now we want the period to be, the period is pi over 2. So I need to do half of that each way. So that means I'm going to go pi over 4 and negative pi over 4. And if I go from negative pi over 4 to positive pi over 4, that's a distance of pi over 2. Halfway between 0 and pi over 4 would be pi over 8 and negative pi over 8. So we can go ahead and list those values out. 0, pi over 8, pi over 4, negative pi over 8, and negative pi over 4. And now we just follow the same pattern with what we did before. So the outside, those are going to be your vertical asymptotes, so that's where tangent is undefined. Negative pi over 4 and a positive pi over 4 in this case. It's going to hit 0 at 0. And then this is a little bit different. Since the amplitude is 2, or the quote-unquote amplitude is 2, that means that it's going to be 2 at pi over 8 and negative 2 at negative pi over 8. So same idea, except it's going to be a little bit stretched out here. It's going to go 2 and negative 2 instead of 1 and negative 1. Okay, so negative 2, positive 2. All right, so that's it. So as long as you remember to put the 0 in the middle, or whatever your phase shift value happens to be in the middle, and then you work to both sides of that, you will always have your vertical asymptotes on the outside, and it will always look like that on the inside.